In a calculation, you need to know the following. You need to know how to add two vectors. Easy, right? You need to know how to add two matrices. This is addition. That means if you have two vectors of the same size, you add them. Let's say 2, 1, add 3, 4. This is two vectors. You add them, then it will be what? 5, 5. You add the first component and add the second component. So what does it mean? If you have a coordinate system, this 2, y component is 1, so this is the first component, right? This 3, 4 was it? Okay, 3, 2, 3, 4. So I have this. You have another vector, right? And then people say, oh, what is a vector addition? You put these in the end, so it will give you 5, 5, right? 5, 5 is somewhere here, right? So basically, it's like you add these two together with this. Yes, this is high school level. Now I'm going to talk about what is vector space, what is linear space, what is subspace, what is linear combination. All of this is because of the understanding. This thing means, you probably don't know, what is this? I have a matrix, 1, 1. Empty means 0. This is the same as I multiply this matrix to this vector. This is what? Well, if I have a vector v, I can always write as a vector u multiply some a. What is this? This is 1, 1, 3, 4. Then they add, right? What is linear algebra? This. Now I have this. I can go back. Then I have 1, 1 multiply what? These two together, right? Well, of course, it's the same thing. These two added up will give me 5, 5. 5, 5 times this is an identity matrix. Then you give me the thing I want. Well, this 1, 1, 1, 1 actually have lots of meaning. First of all, this is our basis. What is the basis? This 1, 1, this 1 in red, think of this 1 is this arrow. This 1 in green, think of this green in this arrow. This stupid equation, which you may think, oh, it's very easy. Yes, calculation-wise, very easy. As I said, calculation and concept. This part, very easy, very tedious. This part, no calculation at all. You can solve it in 1 second, but if you don't understand, you don't understand. Now I'm trying to talk about this part. This 1 means the basis vector in this space with what? X is 1, y is 0. This means what? This means I have a vector here, 1, 0. What does 1 mean? It means 0, 1. What does 0, 1 mean? In two-dimensional space, it means x coordinate is 0, y coordinate is 1. This means I represent a vector 2, 1 as a what? In this red-green coordinate system, this arrow has a value 2, 1. This is important. Who said I need to use this coordinate system? I can use this coordinate system, right? If I use this blue coordinate system, this vector will not be 2, 1 in this coordinate system. Okay, this is my blue coordinate system. My black vector is somewhere like this. Then the x component is like this, right? And then the y component is like this, okay? Then this value is much smaller than this one. Of course, it's not 2, 1. Maybe it's 2, 1, 2. I don't know, but I can calculate. This whole process is the second way you understand what's a matrix. How do I get the blue from the red, green? I do a matrix transformation. What's a matrix transformation? I have my original basis. I call it B1, B2 is a vector. I represent my what? My 2, 1 into this. This is called alpha beta. What the heck does this alpha beta mean? This alpha beta is the following. This thing is called column space representation of this matrix vector multiplication. It means what? If I multiply a matrix with a vector, it's the same as this number multiply the whole vector, and this number multiply the whole vector, and I add them up. This is also known as what? I combine them. Combination. What the heck is this saying? This means what? Linear. So this is what? Linear combination. So what the heck does it mean? Here are so many things that will confuse you. That's why pay attention. This alpha beta means in a coordinate system, when I said a coordinate system, I need to specify what coordinate system, right? So I'm saying with respect to this coordinate system B1, B2, the coordinate of this vector is alpha beta. Nobody said this alpha has to be 2. Nobody said this alpha beta has to be 1. It can be 99, 2000. Yes, I can tell you there exists a coordinate system. Alpha is 99, beta is 2000. Then my job is to find what is the B1 and B2. Then that means that is the same as I solve an inverse of a matrix. How do I solve an inverse of a matrix? I solve a system of linear equations. That means what? I have some unknown here, and I've given you this is 99, this is 2000. Solve this unknown. Which correspond to what? Correspond to the picture that this black vector in the green-red coordinate is 2, 1, but now I need to find a coordinate that this black vector in that new coordinate, let's say the blue one, is 99, 2000. So, in other words, I'm saying, somebody think linear algebra is easy. No, because you have so many things linked together, and if you don't have a very careful understanding of each of the small pieces, you very quickly you get lost. let me go back to here. This means what? A vector can be represented as a matrix multiply another vector. This has a following meaning. Number one, it means this is a basis. These are the coefficients of this vector in this basis. Number one. Number two, it's also the same as I see this as a collection of vectors and I combine these two vectors linearly. So you have two meanings. Now I'm going to give you the third meaning. This row vector dot product with this vector and this row vector dot product with this vector give me this. So they had a third meaning. Okay, you may then wonder, why the heck so many things? So I have what? And then I have some number, x, y. The third meaning is I have this row vector and then dot product with this. So this come naturally to dot product. It will be what? ax plus by on top. And then I row vector dot product with this. So this is cx plus dy. So this is the third way. So let me now summarize. So if I have a, b, c, d, x, y, it will be what? Number one, it will be what? ac x plus bd y. This is linear combination of columns of the matrix. Second view, I have AB dot product XY. So we can think of it as AB dot product XY. And then what? This is the first element. And then I have the second element, CD dot product XY. So CD dot product XY. Notice that I'm using transpose to make it a column vector. So this is the second way. They are representing different things, but they give you the same answer. What's the third way? XY is the what? Coordinate of a vector in the system. Let's say call this matrix A, which is the picture thing I just told you. These three things are the same thing. They give you the same answer, but the concept is totally different. This is called column space. This is called row space. This is called basis, or what? Linear combination, or what? Coordinate transformation. So many things, they have different meaning. So therefore, you have three views. Number one, column space view. Number two, row space view. Number three, coordinate or geometry or vector you learn in high school view. These three things are different things, but it just happened in linear algebra, they're the same thing.